In this video, we are going to discuss problem based on ultracentrifuge. Ultracentrifuge is an equipment used in biomedical lab for the separation of compounds such as proteins or colloids, which consist of particles with different masses through a process of sedimentation. It utilizes centripetal acceleration to speed up the process instead of the acceleration due to gravity. Example 9.4 says that if you want to generate 840,000 g of centripetal acceleration in a sample rotating at a distance of 23.5 centimeter from the ultracentrifuge rotation axis, what is the frequency you have to enter into the controls? What is the linear speed with which the sample is then moving? So here the question has given me the centripetal acceleration AC, that is 840,000 g. G here is the acceleration due to gravity that has a value of 9.81 meter per second squared. Do not confuse the G here with the unit gram. The question says this is centripetal acceleration, so the G here will be acceleration due to gravity. Then I have the distance from the rotation axis, which is R, 23.5 centimeter, which I will convert to meter by dividing this number with 100, and I get 0.235 meter. Question wants me to find what is the frequency f and what is linear speed v. Now we can find frequency using centripetal acceleration because it is related to angular velocity. Centripetal acceleration AC can be written as r omega square in terms of angular velocity. And the reason I'm using this expression is because angular velocity is related to frequency with the expression omega equals 2 pi f. So I can use this equation to find f. Now let's rearrange our terms to write in terms of omega. I get omega squared equals AC over R, or omega equals square root AC over R when you take square root on both sides. Then I will substitute my angular velocity omega as 2 pi f from this expression. So we write 2 pi f equals square root AC over R. Then we divide by 2 pi to calculate f. F equals 1 over 2 pi square root AC over R. So this is the expression of frequency in terms of centripetal acceleration and the distance from the rotation axis R. Now I can substitute the value as 1 over 2 pi square root. AC is 840,000 times G. The value of G is 9.81 over R, which is 0.235. And when I solve this, I get my frequency as 942.9, which is equivalent to 943 Hertz. The unit of frequency is Hertz, which you can also write as 943 per second. Now this is the frequency in revolution per second. You can convert this frequency in revolution per second to revolution per minute by multiplying this number by 60. Because this is the number of revolution the sample in ultracentrifuge makes per second. If I were to find the revolution it makes per minute, I will just multiply this number with 60. So we can write frequency f in revolution per minute will be 943 times 60, which is 56580 revolution per minute. Now, if you do not wish to follow through all of these steps to calculate frequency, you can substitute omega as 2 pi f in the first step here. And when you do that, like if I were to rewrite this first step, and when you do that, you get AC equals R. In place of omega, I will write 2 pi f squared. And then at this expression, you can use shift solve. The reason we do all of these steps is because you need to learn how to rearrange terms. Because sometimes when solving problem, they don't give you numbers and you have to get your final answer in terms of the quantities given to you in the expression. Now let's go to the next part where we calculate the
linear speed.
centripetal acceleration can be related to linear speed by the expression AC equals v squared over r. This is another way of writing centripetal acceleration. So I can find v by multiplying r on both sides. So v squared will be equal to AC times r. Then we take square root of the expression to find v. V will be square root AC times r. Now substitute the values. Centripetal acceleration here is 840,000 times g, which is 9.81. Do not forget to multiply this with g into r, which is 23.5 centimeter. That gives me 0.235 meter. And when you solve this, you get your linear velocity as 1392 meter per second, which you can also write as 1.39 kilometer per second. You can convert velocity from meter per second to kilometer per second by dividing this number with 1000. Now let's discuss another similar problem, which is 9.42. The question says life scientists use ultracentrifuge to separate biological components or to remove molecules from suspension. Samples in a symmetric array of containers are spun rapidly about the central axis. The centrifugal acceleration they experience in their moving reference frame act as artificial gravity to effect a rapid separation. If the sample containers are 10 centimeter from the rotation axis, what rotation frequency is required to produce an acceleration of 1 times 10 to the power 5 g? Again, this is centripetal acceleration and not mass. Do not confuse this g with the unit gram. So I will write what the question has given me. We have centripetal acceleration AC, which is 1 times 10 to the power 5 g. Then I have the distance from the rotation axis, which we write as r, 10 centimeter. And I can convert this to meter by dividing this number with 100. We get 0.1 meter. I want to find what is rotation frequency. So again, we use the same expression for centripetal acceleration. AC equals r omega squared. Divide by r on both sides to leave omega squared alone. AC over r. Take square root AC over r. We know that angular velocity omega is related to frequency as 2 pi f. Let's substitute that here. We write in place of omega 2 pi f equals square root AC over r. So f will be 1 over 2 pi square root AC over r. Now substitute 1 over 2 pi square root. Acceleration is 1 times 10 to the power 5 times g. And g is acceleration due to gravity, which is 9.81 over the distance r, which is 0.1. And when you solve this, you will get the frequency as 498.49 hertz, which you can round off to 498.5 hertz. This is your final answer. Again, if you do not wish to write all of these expression, You can just substitute the value of omega here and you get AC as R. In place of omega, I will write 2 pi f squared. Then you can substitute all the values in this expression and use shift solve to calculate f.